Okay, let's go. So thank you everybody so much for joining, and thank you to Monarhea, I hope I pronounced that correctly, and the Currents team for inviting me to do this. This is really exciting. I think Currents is a pretty exciting project in general, kind of an example of what the internet should be like in general. It's like a truly a community space and a collective type of space. You know, there's a lot of talk out there about decentralization. Um, I don't think everybody who uses those words actually lives up to them, but it seems that this community does. So that's one reason I'm particularly excited to be involved. All right, so we're going to be talking about sequencing and generative composition, and we'll just get started. So today's agenda, I'll tell you a little about myself. We'll do some intros with all of you. And then I'll do some of the housekeeping items, some just logistical items about this course. What can you expect? How do things work? I'll talk a little bit about the history of sequencing, really looking at lots of cool sequencers throughout history, just as a way to understand what is this technique all about and what are the different forms that it takes. And that will bring us to this conclusion of my idea, which is that there are sort of two general methodologies to sequencing. And then if we have time, I hope that we do. If we don't, then we'll just push it to next week. We'll do a little jam session, which will actually demonstrate these concepts of these two different methodologies of sequencing. I'm very excited about that part. If again, if we don't have time, we'll do it first thing next week. So about me, you can read most of the words here on the screen, so I won't go through all of them, but I'm first a musician, second a visual artist, sort of third a programmer, based in Los Angeles. And I work with all kinds of software and machines. I don't have really a traditional musical background. I don't play traditional musical instruments. I kind of came into music through DJing and then started producing and made that my focus, and have used Ableton Live quite extensively, and also have used devices such as the Electron Octatrack quite extensively as well, and we'll talk a little bit about that. And then on the side, I've also for years used Max Msp, where I do visual work, and then I also do recently a lot of sequencing, and that's what we'll talk about in this course. Particularly in the future sessions, we'll get really in depth into that stuff. Today, a little bit more of an introduction. If you have anything to say to me, you can find me on Discord. And why I'm taking this course and why I'm here is for, in one part, just to organize my own thoughts, my own ideas. It helps me to have a little bit of a conceptual framework for what I'm doing, and I think sharing what I'm doing with other people helps me to clarify that information. I also, as somebody who works generally alone, you know, in their studio, on their computer, it's really exciting to connect with other people on these subjects that I'm interested in. And then also I'm very excited just to be involved in Currents space, and this is really sort of my first engagement with Currents, so and I feel very welcome, so thanks to all of you. And then next I will invite anybody who wants to do the same. Just tell us who you are, where you're located. Oh, and by the way, pronouns are he, his for me. What pronouns you use, your background, and why you're here. You can do that in the chat. You can do that in the voice channel here. Just unmute yourself. If you don't want to do that, feel free to skip it, but I'll just leave space now for you all to say hello.
Hello, I'm Dylan. My pronouns are he, him. I'm in LA. I started out as a pianist and drummer, and then got into producing, and then eventually did a little bit of stuff with Max Msp, and started playing around with more hardware, and I do software development, so I really like a lot of the Max Msp side of things, but I've taken kind of a long break from the more generative stuff. And I actually saw Philip play a show in LA not that long ago, and I really enjoyed it. I saw that he was hosting this event, and I got excited. So I'm very excited to see what is in store today. Thanks.
Thanks for getting up early for this, Dylan. Anybody else?
I can go. Hi everyone. I am Manria. I'm a DJ, producer, and creative product, like music recording using SonicFi. And I'm based in Nairobi, Kenya. So for us here, it's like 6 p.m. At least. But I'm excited to learn about this. I recently just finished a 6-week advanced music course, which we like dove deeper into able on live. So having the chance to learn about Max is like exciting for me. And yeah, thank you, Philip, for this. Yeah.
Cool, thank you. All right. Anybody else who'd like to go? Okay. If anybody else wants to say hi at any point, please feel free in the chat, and but we'll move along. So goals. These are goals I sketched out. If you have other ones, please let us know. I think it's really important to me that this is useful and interesting to everybody. I'm not really looking to, express my ideas and make sure that my ideas come across so much as have an interesting conversation. So I think if I really am interested in sort of letting this course go the direction that folks want it to. In fact, I'm going to be producing the content on a weekly basis, adapting according to everybody's interest. So my goal is really sort of learn together about just this technique of sequencing, and it's already been interesting just putting together the materials for today's session to think about almost a theory of sequencing, right? This is a technique that many people use, right? Anybody who's ever made music in a software like Ableton Live or Fruity Loops or Logic is familiar with this general technique, but you can also go quite deep into it, and so I think that's very interesting to think about. How can we make new interesting music by going deeper into these techniques. Second, just reflect on how each of us, how we make music, and how we could perhaps do that differently, or how does this information inform our own practice? And I think no matter how you do things, it's always good. There's no right or wrong way to do anything, and I think that's another thing I want to emphasize. While it's very easy, just like particularly in the computer world, to become very excited about technology and technical things and technical complexity, it's not always, it's only one way to go. So I think anybody who leaves this and says, hey, I want to keep doing things exactly as I am, and that helps to clarify that information, then that's success, right? Third, I am very interested in this question of how does a human being relate to technology when they're making things, or really even when they're living life. Who is the artist? Is it the technology? Is it the artist? Is it the designer of the technology? Is it the user of it? So I think these are interesting questions that we'll get into, particularly when we start to talk about the more generative things, where we are giving a little bit of agency over to the computer to make some decisions, or the way in which we're giving direction to the computer is less direct, is more oblique. And then and that third one I pretty much covered there, right? So speculate on this question of, well, who's actually doing what? There's a lot of talk, of course, in the sort of AI space around, will computers just make the music for us? I don't think that that's true. I don't think that it has to be or should be true. But it does raise an interesting question over what are the complex ways in which humans and computers will interact and do interact today. I'll pause now, just if there's any ideas that come up for any goals that anybody else has here that I didn't cover there. Okay. And one thing to add actually at this juncture is simply that I've made a decision, and that can change if people feel otherwise, but at this point, am not planning to go very far into Max programming. And the reason for that is it's a very dense topic. There are quite a lot of people that do that very well. So if you're looking really to learn, like, how do I get started programming in Max? You could definitely find that other places. The way that I'm structuring this is to think about basically music making technique and then show how Max can be used one way. You know, there's really an infinite number of ways, but one way in which it can be used in the way that I use it. So hopefully it's giving you ideas for if you're already using Max or if you're interested in using Max, how that might be useful to you. But what we won't do is really get into the nitty-gritty of really how to program in Max, because there's so many other resources out there for that. Okay. And then just quickly before we dive in, I want to set out a few just ground rules, principles. All people are welcome in this. All people are welcome to participate in any way that they see fit, regardless of race, gender identity, background, nationality, technical expertise, experience, all of those things. We welcome everybody here. You're welcome to participate as much as you want. There are no stupid questions. There are no stupid comments. This is totally a safe space. We're all learning, and I count myself in that. I think putting this together, one thing that I thought quite a bit about is how I don't really consider myself an expert in what I'm talking about here. I really feel like I'm still exploring it. It's useful for me to share this information, and I really hope that it's useful to you. So I'm looking to learn here as well, and I think that if you have a differing opinion or if you have a different perspective, it's very good to hear that, and I think it makes the experience richer for everybody. And then finally, logistical things. So we'll have a mix of presentations and discussions. Again, discussion is really encouraged. I think if we just talk the whole time about this stuff and we don't get through the presentation, that's good. I also want to add, I'm an English speaker. I know that this is a global audience. If I'm speaking too fast, if you don't understand me, just jump in the chat there and say something, and I'll be happy to slow down or translate whatever you need. You can use the Skillshare chat channel to communicate with the group. If you want to speak out loud and you don't feel like you're getting the space, right? Like if I'm just going on and you don't have a gap, you can just signal that you want to talk in that channel. One common way that I've done it in the past is just type the word stack, and then we'll know, oh, this person would like to say something. I have posted the link. I will do that actually right now. The link to the course overview document, that is sort of your best place to find the general information about the course, as well as the links to this presentation and future presentations. There's also a direct link to this presentation here. Which may be useful to you. Access needs to be granted. Let me just do that really quickly. Thank you, Saad. Change to anyone with link. Done. Okay. All right, let me know if you don't have that, but that should have worked. Thank you. Cool. And then just a note, I'm being recorded on my end. I did not have the technical capability to record everything that is going on here, so when we have this recording, it will be me. Maybe we'll figure out how to do that in the future, but just so you know. So you're not being recorded at all in this, including the text in the chat. Okay, let's actually get into the content here. So just, what is this? What is sequencing? This is my definition. I looked around. There was one on Wikipedia that I actually thought was bad. I thought it was, it's like overly narrow. But my definition is a technique used in the creation of music and other time-based art in which sequencing devices emit data events that control devices that produce or manipulate sound, images, or other media. What does that mean? Let's get into that. So I want to start off with this concept. Synthesizers are not like violins. It's a little bit silly, it's a little bit trite, but the idea that I want to get at here is that the synthesizer, or even really any electronic device that produces images or sound or any form of media, has this interesting property of being able to segregate the component that produces or manipulates sound, images, media, etc., from the devices that are used to actually control that media producing element. So in the synthesizer we have, oscillators, filters, etc., things inside that produce sound, and then we have this keyboard, right? The keyboard doesn't have to be a keyboard, it doesn't have to be shaped like that. It happens to be because there's a musical tradition linked to keyboards, but we can use anything, and it doesn't really change the sound of the instrument. It may change the modes of interaction, it may change some of the ways in which the data flows into the machine, but it doesn't fundamentally change how the device sounds. On the other hand, the violin is this thing that has these restrictions, which we may argue and often do, with validity, that it has these restrictions in its form, right? Its form is influencing both the sound and the playability of the instrument, right? The way in which the person contorts their body around this instrument is required to some extent by the way that the instrument has been designed to produce specific types of timbres. So what all this means is that there's really interesting opportunities available to us in electronic media. So here's many ways that, many examples of ways in which people have been able to send control information, right, of any kind into electronic media devices. And in this case, it's all music. And actually, from now on, I'll refer to synths and music making devices, but I actually want to point out, and I may, I think hopefully, in a later session, get to demonstrating how some of these sequencing techniques could be used for visual work as well, because I do that as well. So on the upper left here, we have a Tao Tanaka who actually uses sensors that measure muscle tension, and that information is then used to control instruments. So he has this very expressive practice. Along a somewhat of a similar vein in the lower left, Sarah Lauren Hayes, who I saw gave a presentation just the other day in San Francisco, who uses PlayStation controllers and other video game controllers and things like this, and she writes software that is a sort of interface between the video game controller and her synths. So in this case, I think I see some kind of Electron Digitact or something like that, and then obviously the laptop. And she has this very cool kind of performance with the PlayStation controller where she's using the accelerometer, she's moving her hands, she's using the buttons, and all of that. On the middle top row, just a good old sequencer, a very fancy one in fact, controlling all kinds of fancy synthesizer gear. That's Max Loderbauer. On the right, the legend, Suzanne Ciani, with her Buchla, using the touch plate that senses, I guess, like electrical signals from the body, and uses that to control the synth. On the lower right, a similar idea, except in this case, the electrical signals are coming from a plant. Actually, I have a friend who does this as well. And then in the middle, bottom row, this is a device that Ableton produced in Max for Live that gathers weather data, and then there's actually, I think, a little synth built into this device that produces sound based on that data. But of course, we understand that the way that they have decided to sonify, produce sound from this information is just their decision, right? We could use this information in any way that we choose. So the point here is, right, we can use anything to control electronic instruments, and that's one of the things that makes them really exciting. It's one of the things that makes performance in electronic media very exciting. We won't talk too much about performance in this course, but it's definitely interesting as well. So back to sequencing. Right? Since we know that we can control devices in many ways, we know that we can also do it using machines. And a sequencer is really like a machine that plays musical instruments or electronically mediated instruments. And if you click this link later, you'll see that it goes to a project by Jordan Hockenbaum from CalArts, who has done he has like a robot orchestra. So he has all of these acoustic instruments like drums, things like that. Oh, my screen share is black. Can other people not see the screen? Let me see. I see it.
I see it as well.
I can see your screen.
Okay. I'm going to keep going. I'm sorry, Saad, that you can't see it. Hopefully that works out. Yes, electronically mediated. So there's some cool stuff. Like I think Aphex Twin did an album too where he had like drums and other devices, and then he had robots actually playing them, and then he had, sequencers controlling them. Aphex Twin is totally like a sequencer nut. So let's go through a little bit, just some history, just kind of for fun, but I think it's also useful to understand what's out there and what are the different forms of sequencers. So the first, arguably, was the piano roll, which is this old technology that allows us to record with analog technology, even before tape. Allows us to record the physical mechanical playing of a piano player and then play that back as data. And one interesting fact is that there are no audio recordings, allegedly, of the famous American ragtime piano player Scott Joplin. There are only piano roll recordings. So when we want to know what it sounded like when Scott Joplin played the piano, we don't listen to a recording of him playing. Instead, we listen to a recording of a piano playing back this data that he produced. And one other interesting detail is that musicologists believe, or historians believe, that the Scott Joplin piano recordings were actually edited by other people after he recorded them. So in this case, we really have something that looks quite a bit like sequencing, where somebody in this sort of offline process, outside of the act of performance, created this data that a machine would then play back. So perhaps that's the first. Another very early one, which maybe this one is the first sequencer, is the Theremin Rhythmicon. Theremin, it's the same person that invented that analog instrument that you can play without touching it, which is totally a cool instrument. This was a keyboard-based instrument that was pretty much an arpeggiator. So you press these keys, and it produces a sequence of melodic pulses. And it actually uses light. It has a lamp inside with mirrors and rotating wheels and photo sensors, and somehow that produces rhythmic sound, which is really cool. But there wasn't tons and tons of activity in these things. These things are pretty wacky, right? And of course, the piano roll is, really designed still to produce and emulate the behavior of a human being. Where things really changed and where these devices really started to become popular is in the early 1970s with the rise of synthesizers. So on the upper left, we have the sequencer from some of the early Buchla modular sequencers. On the bottom is a Korg SQ10, which would very commonly be paired with something like an MS-20, like a monophonic, really cool, acidic kind of sounding synth. And then on the right, the sequencer for the Roland 182, also a modular system. So what we're looking at here are devices that are responsible simply for producing controlled data that feeds into other sound-making elements. So they might send pulses, trigger sort of events, to an envelope that opens and closes a gate that allows sound to pass through. And that creates a pulse-like sound, right, or a sound with an attack and decay. And you can see from the design of these, they're all actually pretty similar and they're pretty simple. In the Buchla example, it looks like we have 4 channels from top to bottom. On the SQ10, it looks like it may be 3. And then on the 182, I think it's 2. And we could see these are simply systems where the system iterates stepwise through these, in the case of the Buchla, columns, and it reports back the value associated with each of these knobs, right? So we could imagine, like if we're just looking at the top row of the Buchla one here, the black knobs, that this knob is used to set the pitch, say, and upon each triggering of each step, it sends that value that indicates the pitch to the oscillator that needs to play that note. So they're really great, they're awesome, but they're pretty simple too, right? It doesn't take a ton of it's not complicated to understand how these work. Around the same time, a little bit later, we started to see come along instruments that integrate the sound making component with the sequencer and are really built for usability and really built as a compact instrument that a musician can afford and can easily use and transport. These systems are bulky, they're expensive, and they require a lot of different components to even make sound, right? These sequencers by themselves, they don't actually produce sound that we can hear. They simply produce information, essentially, that other devices use to produce sound. These integrate everything in one box. So in the upper left, we have the famous Roland Tr808. And by the way, I should have mentioned, I've included links to tracks using these instruments. And so, yeah, you have the link to the deck, and you can come here and look at these. And if we have a few minutes, maybe we can hear some of them. And if anybody really wants to hear one of these together, just shout out in the chat, and we'll do that. But probably everybody here knows about the 808. If you don't, that's okay. But it's on a billion records. This is somewhat later, but also a very simple device. And what you're sort of seeing is over time, these kinds of devices, they become more complex, right? This sequencer on the 808 is very simple in terms of what it can do. And then as you go forward in time, it becomes more elaborate. I have quite extensively used this Octatrack, which has a really excellent sequencer that has a lot of capabilities. For example, it is possible to change the length of the sequence. So you could see there are 16 buttons here. It can go through those 16 and play a pattern that is 16 steps in length, but you can also change that. You can use probabilities, so you can say for a given step, there's a 25% chance that this will go. So there's a lot of power here, but fundamentally it's just a more advanced version of these earlier pieces of equipment. A lot of what I'm now doing, and I still use actually the Octatrack, but a lot of what I'm doing in Max has a lot to do with my attempts to overcome limitations in the Octatrack. And I think those limitations are good limitations. They were designed, that it's part of the design of the instrument, that it's creating sort of a sandbox or a constrained environment within which to be creative. So I have nothing against it. I think it's fantastic. But I found myself desiring certain things, and that was sort of what led me in the direction to start working and doing sequencing in Max, which we'll talk a tiny bit about today and a lot more in the future. Then there's trackers. So these are some of the earliest computer synthesizers, sequencers. And they're particularly interesting because they are, in a way, a very granular, precise version of these instruments. So these instruments use step sequencers, right, that are very similar, actually, The sequencer component is pretty similar to these, right? All the thing does is just count. Just counts along this column, or in the case of the 182, down the rows. And the same on these devices, it just counts through, like if we're looking at the 808, through these red, orange, yellow, white buttons. If we're looking at the Octatrack, through that row of circular buttons. With these, it counts from top to bottom through these rows, and you can put tons and tons of data into these rows, and it's basically a big Excel spreadsheet. They are a little bit of a tedious process to program, but the music that is created with them can be very interesting because there's lots of complex variation in this music. And if you come back later, I recommend checking out this link. This is a guy, Pete Cannon, who is a contemporary artist, but he uses a lot of equipment from the 80s, or sorry, from the 90s, and he's kind of going for this like UK rave vibe, and he's basically recreating, in a sense, this kind of particular style of music making that existed in the United Kingdom in the 90s, and he does it very well, and you can really see very clearly what's happening in Octamed, this software, and how he's producing music. A new review.
There's a really sorry to interrupt.
No.
There's a really good YouTube on the history of like trackers, and it also goes into kind of how they work. I didn't know a lot about them, but it's really fascinating.
Ooh, yeah. If you can find that link and put that in the chat, I will also add it to the deck here. That's got to be fun.
Well done.
Yeah, thanks. Yeah, these are super awesome. It's like, they're really cool. They're really cool. This one on the right, Renoise, is like really deep. A lot of like IDM kind of people use this, like Bogdan Rosinski or this guy Dataset. Okay, and then we have the DAW, which is probably the one that we've all used the most. Certainly the one I've used quite a lot. On the left is the piano roll from FL Studio, formerly known as Fruity Loops, where so much good music has been made. And then on the right, Reason, which is kind of a weird DAW. It's like totally different from any other, but also lots of cool music has been made in there. And you can see on the lower, the sequencer and Reason is this section, this part on the bottom, the kind of like taupe color that says Matrix on it. And this one I think is interesting in that it's really a digital emulation of a sort of mythical hardware instrument. Right? So it looks like a hardware instrument a little bit, and that's kind of how Reason's whole like thing is. It's like virtual hardware, and you can really see this kind of step sequencer energy that it has, kind of moving from left to right with the steps, and from top to bottom is the notes, which really does resemble this piano roll view that we see in FL Studio, and that of course many of you will know from software like Ableton Live. Then we get into weird stuff, and this is the direction that we're going to go in this course going forward. There is a whole world now, particularly, of sequencers in software and in hardware, in the Eurorack world in particular, that are just weird. They are not nearly as clear. You don't know exactly what's going to happen, and there's a lot more going on internally within the device that is responsible for producing the musical or the rhythmic results. So on the left is a sequencer called Rene from the company Make Noise. I don't know actually that much about this stuff because I'm not a modular synthesizer person, but I've seen some videos of this, and it just does a lot of interesting things, and it also is something that you can interact with. So in a way it's a sequencer, but you can also, it has a performance aspect because these sort of gold rectangles are touch sensors. On the right is the Buchla 250E, which is a newer sequencer from Buchla that has just a ton of crazy features and can produce really complex patterns. And with both of these, the point I'm trying to make is basically that the device starts to have a mind of its own. It stops just being sort of a buffer of recorded events that you didactically program as the user, but rather you're sort of inputting information that it then uses to produce rhythmic information according to its own logic. A couple more examples of sequencers of this type. Hello. Beautiful. I'm going to mute this person that just joined.
At least one person.
It is cool what's happening there, though. But I'm going to mute you. Okay. Two others. This Euclidean circles is a sequencer that, and you'll actually see this Euclidean technique in action later because I use it quite a lot. But the idea here is that it uses a simple mathematical algorithm to produce rhythmic patterns with just 2 or even perhaps 3 pieces of information from the user. So, and those are just 3 numbers. So I could say 4, 6, 5, and it's going to produce a pattern for me, which is pretty cool. So you can really control this thing in quickly and easily by just changing those values. So if I 4, 6, 5, and then I go to 2, 6, 5, and then I go to 7, 9, 3, it's really changing the pattern. And I'll show you in much more detail later how that works. But this is, I think, maybe one of the best examples, simplest examples of an algorithmic sequencer where I'm not saying, okay, on step 1 do this, on step 2 do this, on step 3 do this. Instead, I'm just saying, here's some information that feeds into a function that the device then uses to produce rhythms according to its own logic. On the right is a programming language, I guess, or sort of a piece of software called Tidal Cycles, which I was in San Francisco for a conference over the weekend, and a lot of people were using this. It was really cool. I have not used it personally, and I don't know a ton about it, but what I do know is that its sequencing logic very much works according to this kind of idea of functions. So I'm sure there's a very simple way, for example, to produce a Euclidean pattern, just like this Euclidean circles device can produce. And there's other ways to sort of send commands to pattern generating functions that change how the pattern is generating those functions without you having to very precisely say for each step what should happen. And the result, which I heard quite a bit over the weekend, is this very sort of evolving rhythmic music that is able to retain a sense of a groove without feeling repetitive, right? Because there sort of can constantly be change, but if you're skilled at using it, you can maintain this idea of a kind of a rhythmic pulse or a sort of a groove to the music, but it remains interesting. And the capabilities of this thing go far beyond just this idea of pattern production. You can see, just as an example here, we have this, this part that says octave 5/7. I don't know exactly what that means, but what it implies to me is that there's something going on where it's creating kind of a using similar types of systems, algorithmic types of systems, to produce changes in pitch in addition to changes in rhythm. So I'm already getting, I'm pretty much there, but I will kind of clarify this. Oh, sorry, one more slide, which is Max. So this is, another environment where you can do these sorts of things. On the left is a screenshot of my own system, which I'll get way more into, but basically the way that I have built it, and to be very clear, Max is, it's really a programming environment, even more, I'd say, than Tidal Cycles. While Tidal Cycles looks very technical in its code, it is not something, as I understand it, that you would use to make software. It's more something that you would use to produce music, by which I mean, these functions, sometimes with speed, gain, these are, they're specifically for music creation. Max has, and that's great. I think that's fantastic because it makes this a very, very interesting and very creative tool. Max is in ways more flexible because when you start with Max, you have a blank slate, and from there you produce what you want. And some people work with Max in a way where they sort of produce a patch that is itself a composition, and other people work in a way where they're sort of creating a piece of software for themselves that they then use. With this, I'm operating in that second category. So just to give you a brief explanation of what's happening here, and we'll talk way more about it in the future, each of these boxes is a module, basically a little device that I've created, and then I can connect these modules to each other in flexible ways to produce rhythmic music. That's probably all you need at the moment, but understanding that each of these blocks, for the most part, like these boxes with the sort of gray banner that has some name like E chroma or 8 chroma or E1 or E2, those are pieces of those are devices that I've made. And then on the right, sequencer from the producer Goose out of Shanghai, who I think is pretty active in this community, or at least has a channel part of the Subcult collective whose music is really sick. This is their device that you can find online. I have the link here. I've not used it, but I know that this person's music is really awesome, so definitely worth checking out. And this is made in Max. This is actually probably a good idea to just talk about what's Max MSP versus what's Max for Live. So Max MSP is its own standalone sort of programming environment. Max for Live is a system where you can build a device in Max and you can actually run it in Ableton Live just like any other device. And most people who have used Ableton, especially the Ableton Live suite, have come across this, or many of you may have come across this in some way, shape, or form. And there's tons of devices out there that other people have created that are just freely available Max for Live devices. And if you're the user of them, they seem just like any other ordinary Ableton device that you drop into the insert chain. So you can, I think, download this device and just use it. But thank you, Philip. Have a nice day. But you can also make your own stuff. So we'll talk more about Max for Live. I'm guessing that's going to be interesting to people. And in the future, we can talk a little bit. I think an interesting conversation will be to talk about why might you want to use Max for Live versus why you may want to just work in standalone Max, which is what I usually do. So we'll talk about that in the future. Okay, so through this discussion of sequencers, I'm getting to sort of a point, which is kind of my theory of sequencing, or at least part of the theory of sequencing. This is totally my idea, by which I mean, other people may vehemently disagree, but I sort of see there being two methodologies. The first is what I would call deterministic. So this is this idea that the inputs that I supply as the user of the sequencer, I understand very clearly what that's going to mean in terms of the sort of result, the musical result. So if we look at this Doepfer sequencer, we can very clearly see it uses that very simple step sequencer design where it iterates from left to right and it reports the value of each knob. So, if I want to change the value of step 6, I can do that. It's pretty straightforward. Then there's this other category, which I would probably call algorithmic, which this Euclidean circles demonstrates, where my input as the user of the sequencer is not so much the value of step 6 or the value of step 12, but is rather information, data that the sequencer's algorithm will use then to create musical information. And I think I've already explained that hopefully well enough for it to make sense. So both of these techniques are awesome. Most contemporary sequencers particularly include some combination of these two things. So it's not like, you're all one or all the other, typically. And I use both of them, but I think one thing that has become very interesting to me is this second category And it's this sort of stuff that I've been pursuing with my work in Max lately, and that's what I want to talk to you all about over the next next 3 weeks. Okay, so we have 8 minutes, which actually is perfect, and we are going to use that time interacting hands-on with sequencers as a way to sort of understand the difference between these two things. And we're super lucky because there is a web-based sequencer that exists that actually has 2 versions, one that really operates according to this deterministic logic and one that operates according to this algorithmic logic. These sequencers were created by 3 people, Mark Fell, Roland Tr808, and James Bradbury. And they're multiplayer sequencers. So it works a bit like a chat room where when we click one of these links, we will actually we will all be in the same sequencer, and we'll all have access to the controls, and we'll all hear the results. So I hope you'll join me. I would say just go into whichever one you want, and if you want to switch, you can switch. We're both going to be in a room called Currents, so we can all mess around. I'm going to mute my computer audio so that the audio that you're receiving should be just coming straight out of the sequencer on your end, and hopefully it just works. It's pretty straightforward, but yeah, so you should have the link to the presentation, which I'll post again in the channel, and whenever you're ready, just dive in. Actually, you know what, I'll just straight up post the links to the sequencers. So there's those links. The first one is the deterministic version. The second one, the AAA one, is the algorithmic version. So I will see you there. Oh, I might be. Does it not work? Ah, here we go. Ah, there we go. It's kind of lagging for me. I am having some trouble getting it to respond to my input. Let me try the other version. Oh yeah, Mark Fell's book is super awesome. I am also reading it. We're going to talk more about those concepts, actually. The second one is super crazy. Monray, can you figure out how it works is the question. I saw a performance over the weekend where James and everybody played the synth, or the sequencer, and we were trying to figure out how it works and like what it's doing. That was fun. And you can see if you're in the first one, and if you're not, don't worry about switching. But if you're in the first one, or if you're looking at my screen, you can see that while this one is mainly deterministic, right? I can just put these steps in, and it will play back the pattern. I would love like a bass drum. Oh God, that's cool. But anyway, while it's mainly deterministic, there's actually a little bit of an algorithmic component where if I use this pattern knob, it's going to produce a pattern using the aforementioned Euclidean algorithm. And I can change the length. Oh, there's the kick drum. Oh, yeah. Maybe a little faster. Hello, Paul. Cool, those are also things I'm into. I've not used an MPC, but they seem awesome. It's cool that there are a lot of people here who are proper musicians as well. That's exciting to me. By which I mean play instruments, play drums, play guitar. Oh, nice. Somebody's in there changing the pattern in my room. Yeah, get in there. Yeah. There you go. Yeah, if you haven't heard Mark Fell's music, it's awesome. I particularly recommend the Sensate Focus. I'll type it in. Yeah. Yeah, probability in here would be kind of awesome, wouldn't it? Yeah, one thing I think is particularly great about this device is how... Oh, yeah. We got some crazy stuff going on here. One thing I really like about this, though, is just how... it's pretty simple. Like, you can start using it, but the complexity that you can get from such simplicity is deep. Yeah. like the sound knob is just so, there's so many cool sounds with just, 3 knobs. What's your favorite Sensate Focus track? I wish all like dance club music sounded like that. Maybe not all, but I wish there was more club music like that. I remember I was talking to some DJ and they were like, "Yeah, those tracks are cool, but I can't play them because they don't mix with the other house music I played." And I was like, "Well, might have to just, cut abruptly because they're so good." Yeah, Ryan Triner's really great too. That Ataxia record. And then also in the same vein as that Gabor Lazar guy, whose new record just came out, Boundary Object, I think it's called. It's extremely good. Also made in Max Msp. Oh, I like that. Whoever's at the controls right now is killing it. I want to go to the rave that you play. Cool, thanks. See you later, Wambui. I think I might jump off in maybe 10 minutes as well. Need to go have some breakfast. Yes, thanks for facilitating as well, Wambui, in the chat earlier, in the Skillshare yesterday, schooling me on Discord and the RSVPs. Yeah, and I already said it, but I also want to give a shout out to Monrea, who has been a guide to me through this process, getting me set up. So thank you so much. Yeah, you could really go for hours playing this thing. Yeah, what does that shape scale knob do? Oh, cool. So that's like the envelope, right? That's like basically how long the sound is. Yep, then we have the pitch. So this thing is really awesome, and one of the things that's super cool about it is, and they were explaining it over the weekend, I went to this like event, that everything that's happening in terms of the running of the sequencer and the production of the sound is actually happening on your computer. And the only thing that is sort of shared between all of the different people who are in the same room is the settings of the sequencer. So anytime somebody does something, you just get a little update that says, oh, hey, change the value of parameter whatever, and then your machine plays back the sequence according to those new settings, which allows the thing to be very responsive, and also it removes any latency type of issues. Right? You're not gonna buy Panda Bread brand. Thanks for coming. Yeah. I heard about some folks who were using this thing, and it was a man and his daughter, and they used it together in the same room on 2 different laptops, and they were like, wait, what's going on? Because the audio was out of sync between the 2 of them. Because the thing is really designed to be used by groups like us that are all remote. So I'm probably hearing things, maybe a half a second before or after you, but that doesn't really matter because we're not next to each other. Thanks, Sod. Me too. I'm looking forward next week as well. See you later. Ooh, I love that sound. Yeah, that bottom row. Yeah, these guys are saying when they did the when they were working on this, they had to make the sounds. They're using FM synthesis, and FM synthesis is very powerful, but it's very complicated. But Mark Fell knows it quite well, and there's many parameters. And so what they did was they had like pages and pages and pages of knobs, so that the artists who were working on this could actually figure out what the sounds should be. And then they sort of condensed these different sounds, creation of these different sounds, down to really just this sound knob, as far as kind of how the synthesis algorithm is working. And then obviously the pitch is simple, and then the shape is just the envelope. So there's like a ton going on behind the scenes behind this sound knob, and I think that's really part of the sort of art of this project, is things like that, where they've taken a complex idea and they've broken that down to something actually quite simple, so that when you're playing it, it's a fun and creative process. Ooh, I love that. Ooh, that snare is great. Ooh. I love how you're modulating is somebody modulating the pitch on that snare too? It sounds great. Ooh, yeah, that's so good. Reminds me of like a marching band, like a, ooh, I love that. Oh, I'm glad you liked it, Dylan. I believe that is Dylan. Calculated, or I have fun. Thank you. See you next week. Oh, this is interesting. This multiplier will like jump steps. That's very cool. Oh, I love the wander. It's not purely random. It's like a drunken walk. It's like each time it's at a given step, it basically has a 50-50 chance of going to the left or to the right. So it can get stuck on a region for a little bit, but then it eventually will escape. I don't know how many people are looking at my screen versus the other one. The other one is really cool. I just couldn't get it to work. All right, for anybody who's still on, I am going to jump, go have a little bit of breakfast. Thank you so much, everyone, for being here and everyone who's still here. And we will see you next week. Goodbye. Bye-bye.